We begin to think we know a lot about something when we keep learning new information about it. But in terms of space, this isn't always the case. You'd be shocked at how little we know about our solar system, which is far, far larger than you might anticipate. However, that could soon change with the arrival of a next-generation telescope. Does this imply that the elusive Planet 9 might eventually be found? What additional mysteries does our solar system have for us? Would our perception of our position in the universe be altered by all of this? Prepare to learn the answers to this and other questions now. This enigmatic planet orbiting far beyond Neptune is known as Planet 9, although it was also known as Planet X prior to Pluto's reclassification. Scientists have been baffled by it for decades. Astronomers have suspected the presence of a massive planet impacting Uranus and Neptune since the turn of the 20th century. However, as Voyager 2 reached Neptune in 1989 and returned data, it became evident that our calculations were incorrect. As it happened, the two gas giants were not strange in any way. It appeared that the search for Planet X had yielded no results. However, it wasn't the last. Recently, an inquisitive scientist made the decision to examine 38 years' worth of data from the infrared astronomical satellite, IRAS, the first telescope to successfully scan about 96% of the night sky. Additionally, out of roughly 250,000 point sources, 3 stood out as particularly intriguing. But how would you search within our solar system for something? Using a telescope, you can view a group of dots in one particular direction of the night sky. There are stars in the distance, and things in the solar system are among them. So, how do you tell the difference between the two? You observe the movement of an object. It's likely positioned fairly far away if it moves very little or not at all. However, it indicates that an object is sufficiently close to our solar system if it travels a considerable distance in space in a comparatively short amount of time. Out of the 3 objects in the IRAS data that satisfied astronomers' criteria, only one was seen traveling across space. The scientific community was ecstatic at this point. We have been searching for a planet that, if the IRAS data is accurate, should be 3 to 5 times as big as Earth and orbit at about 225 astronomical units. 1 AU is equal to 149,597,870.7 kilometers, 92,955,807.3 miles, from the Sun. However, such a conclusion was not shared by the other 2 scientists who were part of the search. They did discover an additional idea regarding Planet 9's existence, though. And once more, the search took a different turn. There are 6 space objects known as extreme trans-Neptunian objects, ETNOs, that are located beyond our solar system. They're not just any old things either. They all have an intriguing characteristic that piques scientists' interest. Each of the 6 has an orbit that points in a single direction. And since the likelihood of such far-off space entities aligning in this way is about 0.007%, we may be certain that something is at work. An external force from a considerably bigger body in the distance. A planet nearly as large as Neptune and with a radius 2 to 4 times that of Earth may account for all the unusual events. Moreover, its orbit would be extremely eccentric, approaching our Sun at roughly $200 and then veering off at an astounding 1,200 Australian dollars. The orbital period of such an extended orbit would be 20,000 years. The only thing missing from the scientists' theory were a few objects with even more bizarrely extended orbits. However, as it happens, an additional astronomer has now found these objects precisely where our hypothesis suggests they should be. However, being aware of Planet 9's orbit does not provide information about its current location. However, scientists are certain about some things, and they can forecast where to hunt for some things based only on logic and mathematics. For instance, Planet 9's brightness is 18th magnitude at its closest point to the Sun. Therefore, it should have been easy to see if it had lately passed so close to Earth in its orbit. As a result, we believe it to be nearer its farthest point, where it is more difficult to see and as weak as 25th magnitude. How much light is that? The brighter the object, the lower the number. Pluto's typical magnitude, for comparison, is about 15. Fortunately, the Hubble Space Telescope can still identify objects of 25th magnitude, which is 10 billion times fainter than what is visible to the human eye. Therefore, even though its exact location is unknown, we have reasonable evidence to believe it exists. You would believe that with the data at hand, it is impossible to detect a planet this far away, yet we have previously discovered a planet, Neptune, based on our predictions. The ancient astronomers could not come up with a plausible basis for their belief that Uranus was being pulled in some direction. Subsequently, a scientist estimated the location of a hypothetical planet that was thought to be responsible for Uranus's current state using traditional celestial mechanics. In just one night, astronomers were able to pinpoint Neptune precisely where it was anticipated to be, thanks to those calculations. But Planet 9 is anticipated to be far farther away than Neptune, which circles our Sun at a distance of roughly 30 astronomical units. Our prospects aren't very great because of the huge distances and how dark Planet 9 is. However, things could quickly alter. The Vera Rubin telescope, one of the upcoming generations of telescopes, is presently being constructed in Chile. With a 3,200 megapixel camera on board, this 8.4 meter, 27.5 foot telescope is expected to start operations in the fall of 2023. It is anticipated that the car-sized camera would be the biggest ever built for astronomical purposes. With the use of such a gadget, scientists might discover over 20 gigabytes of space objects and other phenomena in a single night, in addition to confirming the existence of Planet 9. The observatory will be able to gather more data about space in less than a year than all of Earth's telescopes combined. This has the power to completely alter our understanding of the cosmos and our role in it. Please let us know if you would like to watch a full video about this telescope and the potential discoveries it could make. However, what would happen if we looked everywhere in the sky to see where Planet 9 might be and found nothing? According to certain theories, Planet 9 might be confused for a primordial black hole that would produce comparable gravitational effects. Primordial black holes burst into and out of existence in a split second during the early stages of the universe, when everything was considerably denser and hotter. However, this is all theoretical because we haven't found one yet. Furthermore, the mass of that black hole might have been as small as 5 to 10 grams, 0.17 to 0.35 ounces, or as large as 100,000 solar masses, depending on when in that second it was born. The problem is that a primordial black hole with many times the mass of Earth would be a little bigger than a grapefruit or even smaller than a human fist if our calculations about the mass of an elusive planet were accurate. If that's the case, there's no way we'll ever be able to discover it with a telescope. Still, we might just use a more forceful approach to find it. The plan is to launch dozens, if not hundreds, of tiny laser-powered spacecraft to investigate the gravitational field of a potential primordial black hole. It would be sufficient if even a small number of these tiny spacecraft were to pass a black hole at a distance of tens of astronomical units and return data to us. However, how could we tell if we were correct? By analyzing the time intervals between those signals, we could determine whether or not a black hole is indeed present. The signals will get longer if this enigmatic object is there due to its gravitational pull. Indeed, there are many hypotheses about Planet 9, and that's not even the end of them. It's possible that Planet 9 was once a rogue planet, or something similar, that was roving aimlessly through space without a fixed orbit. And at some point in the past, the gravity of our star might have pulled it in. You might find that counterintuitive, yet research indicates that there are more planets in our galaxy that are not orbiting stars than there are that are. It's interesting to note that, based on simulations, rogue planets simply join solar systems and exit them in 60% of cases, but in 10% of situations, they have the potential to take another planet with them. However, once a rogue planet joins a solar system, there's a 40% chance it won't be able to leave. That is one theory as to what Planet 9 might be. Furthermore, we have previously found a few rogue planets. It is difficult to find such worlds because nearly perfect alignment is required between an observer, a star behind the planet, and the rogue planet. And the only way we can tell it exists is if, as a planet passes by it, the light from a star behind it is bent by its gravity. Two such incidents with confusing names turned out to be good candidates for rogue planets. One of them may be as huge as Jupiter or possibly a brown dwarf, while the other is thought to have a mass range between Neptune and Earth. Four potentially new Earth-sized rogue planets have recently been found by the Kepler Space Telescope straying through our Milky Way. Although little is known about rogue planets at this time, it's intriguing to note that some scientists believe they may be livable. However, how could life exist in a world with insufficient light? Subterranean oceans, tidal heat, and an active galactic core are the three possibilities. It is true that there is very little chance of life existing on the surface of such space objects. However, subsurface oceans might also be home to larger organisms in addition to microorganisms. Some heat would be trapped by the interior of a rogue planet or its extremely dense hydrogen atmosphere, preventing these oceans from freezing. Jupiter's moon Europa, which is pronounced Europa, is a frozen object with liquid water on it that is even within our solar system. One possible source of tidal heating for such a planet would be a large moon around it. If a smaller celestial body orbits a larger one at a close distance, the smaller body's shape would be distorted by the larger body's gravitational pull, heating the item in a manner akin to how heat builds up when wire is bent. It would also be possible for a rogue planet passing close to an active galactic core to receive enough light from the galaxy center. Furthermore, a rogue planet may be able to support photosynthesis as long as it remains 1,000 light-years or less from the galactic center. With its 4 massive worlds and 4 smaller planets, our solar system is a peculiar place. This appears strange to scientists, as though something is missing. And how likely is it that astronomers operating hundreds of years apart will consistently reach the same conclusion, that something exists? Slightly more than 130 astronomical units, AU, separate us from Farfarout, the farthest object in our solar system ever discovered by man. At that time, you can calculate the farthest point of Planet 9's orbit by adding 1,000 Australian dollars. Thus, although we have a long way to go before we become experts at searching, the Vera Rubin Observatory should be a significant step in the direction of learning more about the enigmatic world in which we live. Thank you for viewing, and check back soon for more fascinating insights into the cosmos.